Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super, and the outage we're going to talk about today happened on the 21st of January. It was an outage that was impacting ARM, our Azure Resource Manager service. It's a global service, but not all the regions were impacted. And joining us today to speak about this, we have Nadeem Abdo, our Corporate Vice President of Engineering for Identity and Access Management.
And we've got Brendan Burns, our Corporate Vice President of Azure Cloud Native and Resource Management. So we'll get time with each of them today. Brendan, maybe I'll start with you here. I think before we get into the specifics of the incident and what happened, what went wrong, could you at least help us to understand the ways in which ARM, our kind of resource manager, talks to Entra and what kinds of things they interact with?
Sure. I mean, I think it's important to understand that the Azure Resource Manager is the control plane, the gateway to Azure. Everything that you create, update or delete in Azure is done through the ARM control plane. And of course, when you create resources, whether it's a virtual machine or a database or anything else like that, we need to know who you are. And we need to know what you have access to. We need to know in the context of what corporation or what we refer to as a tenant you are part of. And so all of that information is stored in our identity system, which is Entra. And so I think, really ARM interacts with Entra the same way anyone would interact with Entra to figure out, like, who are you and what do you have access to and what organization are you part of.
So that makes sense. And in our PIR, our post-incident review, we said, hey, there was a bug. There was also a private preview feature with continuous access evaluation. And all of these were contributing factors to this kind of a series of unfortunate events lining up. Could you walk through kind of how all these things kind of align to create this incident?
Sure. I mean, we're always developing and evolving the Azure Resource Manager, adding new functionality, adding new features. And, generally, when we do that, we start out by putting it into what we call a private preview. And if it's a private preview of a feature, it's something that we are going to only open up to, some internal teams for testing, as well as a few external customers who have been the ones who've been, agitating for that particular feature or that particular capability, the people who either really want it or really need it for some reason. And, the way that we identify who should be in this private preview is usually by an identifier like tenant ID. And so a company will have a tenant associated with all of their users, and they will come and say, hey, we would like to be in this private preview, and we will add them to a configuration that we send to all of the ARM instances that says, okay, for this tenant, light up this capability. And so you can think of it, if you're not in that list of tenants for the private preview, if you try and access that capability, you wouldn't see it. It wouldn't be there. And if you are in that list, then you get access to that functionality. And the functionality in particular that was being implemented here was a conditional access evaluation, which is a feature that allows you to sort of shape who and how people can interact with the system.
Got it. That's helpful for us to understand some of the different moving parts. As I was kind of trying to understand this incident, Brendan, help us. How did hitting a bug on one tenant end up impacting other tenants or other systems? That leap sounds like it's something that isn't very well understood from some of the customers reading the post-incident review.
Sure, and I think that's the crux of the issue. And there's a lot of different repair items from this issue, but I think it's one of the more important ones. When the feature was implemented, you have to go and load some information from the tenant. You have to load its policies in order to enforce those policies in Azure. And I think traditionally, especially with full production services, we do that kind of loading on demand. There's a lot of tenants available, and we can't even keep all of that information in memory at all times. But for this feature, the developer who was developing it, I would say, took a little bit of a shortcut, or maybe a design that slipped through that shouldn't have, and they loaded up those policies into memory for all of those tenants in the private preview in the initialization of the server. So obviously anyone who's written a server kind of knows that there's sort of two phases in its life. There's the period when it's gathering all the information and all the configuration that it needs to run, and then the period where, that's what we call initialization, and then there's the period where it's up and it's running and it's servicing requests, and individual threads handle individual requests. The challenge here was that the initialization code included obtaining a token from that tenant and then getting the policies from that tenant as part of the initialization flow. And now, obviously, the person who was writing this code understood that failures could happen, and actually had retry logic in place to try and defend against these failures. But ultimately, after enough failures, the code as written gave up and terminated the server process, and that was the root. That was the problem. That was the root cause of how this, single tenant that had a change then impacted ARM everywhere, because over time our servers wouldn't come up, and eventually we lost enough capacity that there was customer-facing impact.
You bring us such an interesting point, because as ARM instances would reboot, they wouldn't come back online, and so the capacity loss of the ARM instances was gradual and it was slow. And I imagine that there's natural kind of movement every day, week, and month in the ARM instances. We have unhealthy instances. Is there a monitoring gap? At what point in time did you get to 1, 3, 5, 10%? At what point in time do we say something's going on here and we have a huge crisis? Because I can imagine that kind of creeping up slowly. I'm interested to know about how we look at ARM instances.
Sure. I mean, as you say, there's organic change and organic restarts that happen. Some of this is actually as a result of like a deployment, although that wasn't true in this case. Some of it is due to transient, failures in the underlying hardware, perhaps, or in the underlying operating system. And we actually also proactively recycle these instances spread out across the day, to catch things like resource leaks and other things that, can creep in via bugs and can have impact on the users. If you use up all your file descriptors, or you use up all your memory, that can have impact, or all the threads that are servicing requests, that can have impact on the end user. And so we recycle these processes periodically, spread across the day, so there's not user impact. We take them out of the load balancer, recycle them, and then restart them and put them back in. So that organic process was happening. And you can actually look at our monitoring graphs and see sort of gradually over time, the instance count was decreasing. Now, the way that we've approached monitoring in the past, and I think generally is the right approach, has been not to necessarily look at details like, is the CPU running hot or things like that, but rather looking at the user-facing SLO and SLIs. So I think there's been a number of conversations about, the service level indicators. And in this case, as we lost capacity, our service level indicators were still very green, because in part it was a Saturday, and so load was a little bit low, but also we over provision in to be ready for spikes and things like that. And so initially, as we were losing instances, our user-facing SLO, in fact, for 4 or 5 hours, our user-facing SLOs and SLIs were at 100%. Right? We were servicing all the requests because the the instances that we were losing weren't critical, weren't necessary for serving that amount of capacity. Now, in retrospect, I think that what we should have said, and I think we now have I know we now have in monitoring, is that while the instance count may vary over time due to sort of drift, it should never be monotonically decreasing, right? The slope of that line, if you sort of look at it over time, should be flat. It shouldn't be headed down. And so, because obviously if the slope of the instance count is headed down, you project it forward into time, there will reach a point where you no longer have capacity to serve all of the requests that are coming in. It's not now, but it is out in the future. And obviously when that happens, it's very user impactful. And unfortunately, that's what happened in this case.
Got it. That's great to hear some of the monitoring improvements that can come out of this for this kind of failure mode here. I've seen several questions, Brendan, that come through from customers talking about private preview that seem to focus on this element of we must have lots of private preview features floating around. Does somebody need to go through with a fine-tooth comb and find all of them and check all of them? Is that the right way to think about bugs in private preview features generally, or can that kind of thing not really be avoided?
Well, I mean, I think bugs in general can't be avoided. We do a lot of work to try and prevent them. We do a lot of work to try and catch them before they're user impacting. But I think bugs will be with us always, I think is the truth. In this case, I think the place where we really want to put a fine-tooth comb, both in terms of practice as well as in terms of introspection of existing code, is not necessarily in the private preview features, but rather in the initialization code of the server. Right? Because if the private preview is implemented solely in the request handling path, even if it crashes, it only takes down the instance that is servicing that particular request. And that's a much smaller blast radius than every single server going down. And so I think the critical section, if you will, is that everything that we do between when we start and when we're serving requests, all of that code, because it has the ability to take down all of the ARM instances, is code that deserves special care and deserves special, both software design and code introspection to ensure that we're doing the right thing there.
So one of the attributes of this outage is that we know West Europe didn't recover quickly, and we spoke about the West Europe being overwhelmed. Brendan, I remember speaking to you about a year ago after Southeast Asia. And we had an issue where we spoke about the load balancing nature of ARM, and you were talking about ARM is currently DNS load balanced, and you were moving to L7. One of the issues back then was because it was DNS load balanced, we overwhelmed East Asia. Did the same thing happen here with West Europe because we were still DNS versus L7 based? And is it the same kind of attributes and players at play, or is it something different?
No, unfortunately, this is a very different cause. Effectively, there are several properties or several services in Azure that have what we call data plane RBAC. So a good example of this is storage. There's a representation of a storage blob or a storage account or a storage table in ARM. That's the control plane resource. And users have access control to that to read or write or delete or whatever it happens to be. And you want that access control to be consistent, whether they're looking at the resource object itself or they're interacting with the storage table. So, if they can delete the storage table in ARM, they should be able to delete things from the rows in the storage table in what we would call the data plane of the storage table. And similarly for create and read and all of that sort of stuff. That consistency is important to our end users. Of course, in order to have that consistent RBAC, the storage stamps have to talk to ARM periodically to refresh their RBAC data, their access control data. And in this case, because of the duration of the outage in West Europe, there were a lot of storage stamps that needed to refresh their data and hadn't done so successfully. That led to a significant flood of traffic when we started to come back up. It was exacerbated by some code bugs in the retry logic for storage that that amplified the flood and made backoff not happen for certain HTTP error codes. And the net result of that was that the traffic volume in West Europe was significantly higher than we would see even on a peak day. But it was all coming from inside of West Europe. It was the storage stamps in West Europe talking to the ARM in West Europe, which is what we want to have happen, in terms of regional isolation and load balancing.
That's interesting to understand kind of the West Europe specific impact here, because as I was understanding it, we mentioned 5 regions in the post-incident review that were kind of the most impacted. Am I to infer from that most other ARM regions had some degradation but were still able to serve users? And did some regions escape entirely? We've seen a lot of reports, Australia regions and even some APAC regions actually didn't run into some of these ARM failures. Can you just help us understand a bit more about what that felt like in different regions?
Yeah, I mean, so there's 2 aspects to this. One is that all of these instances service management.azure.com. So depending on how your local network is set up, your corporate network is set up, even if you're in one region, you may actually end up talking to an ARM data center in a different region if your corporation or your network provider egresses that traffic in a different place. So sometimes that happens. But also because of the nature of the outage, it was some of our highest traffic regions that suffered first. And so I would say every single region in ARM had at least a few of these crashes. But many of those regions didn't reach that tipping point where the number of instances that were available was fewer than the number of instances necessary to serve the user traffic. And I think partially because of the day-night patterns of where people were awake and where people were working or not, the US and West Europe were disproportionately impacted. But had we not taken action when we did, people in other regions would have been impacted as well.
Super, thank you very much. Nadeem, I was hoping I could turn it to you. Azure Resource Manager ARM, it's a control plane, so we're spinning up resources, deleting, scaling, and generally if the control plane goes down, customers can't do stuff to their resources. But in this instance as well, the data plane, which means the availability of the service itself, it was impacted for some of the services that you oversee. Could you talk us through what happened there?
Yeah, so that's correct. Some of the services, in particular, Azure Key Vault was one good example, was impacted on the data plane for some users. And again, it has to do with something that we actually recommend, which is to use Entra for RBAC. Those systems were using Entra for RBAC, and similar to what Brendan described earlier, on the data plane, those services, like, for example, Azure Key Vault, have to be able to make decisions about who has access to what vaults. And to do so, they cache a variety of RBAC data. RBAC is role-based access control. These are things like policies, role assignments, and they cache sufficient information to be able to make such a decision. The outage was prolonged enough that those caches began to expire. And when those caches needed to be refreshed, we had a dependency on the control plane for the refresh of the cache, in effect by going through ARM again. And that's something that we're actively working to decouple between Brendan's team and my team for our services, such that the data plane services will have much longer caches, able to in the first place write out any kind of issue and outage, and secondarily to not have that path that relies on the same control plane. And instead rely on in-region service endpoints that they can query directly to refresh their RBAC data. And those will be highly available and distributed. And the idea is that you'll be able to continue to serve your RBAC requests. Even if there is an outage, you may be stale slightly in your policies. In other words, you might lose the control plane ability to update your policies, but you'll be able to ensure that we continue to service them and perform the correct authorization checks as of how they were last set. And there were some, we did mention in the document, there were some more minor secondary issues that also occurred in Azure Key Vault that were highlighted when we were running under this overload condition. Those are more tactical repairs that we've already made.
A quick follow-up question about the kind of data plane impact there. Was Entra impacted by not being able to kind of spin up, spin down? We know there were some downstream services that couldn't scale up because of some of the ARM issues. Did that impact any of the services within your space, Nadeem?
So there was no impact to Entra itself, as in general authentication. There's no impact to user authentication, traffic to things like M365. The specific service that serves these RBAC data plane refresh requests itself was overloaded as part of the surge in traffic that Brendan mentioned. And it did indeed have some issues in recovery that are, again, similarly due to their dependency back on that control plane. There again, this is not something that every service has to take care of. We expect services to be able to rely on the highly available control plane. For deep infrastructure services, we have a range of additional resilience strategies where if the control plane is not available at the level that normal services would interact, they have other mechanisms that we're adopting. And this is true for my services in Entra and Brendan's team as well. We're working on similar paths.
Super, thank you. A question I'd like to ask, I'd like to direct towards both of you. Generally, when we make changes in Azure to services, if you take a look at any service, it does things in a stage place. We do it region by region. We don't do zones at the same time or region pairs at the same time. But ARM and Entra are slightly different in that you're global services. And so when you're making change to global services, is it different? How do you make change in a modularized way with trying to encourage fault isolation? I'll start, Brendan, with you just alphabetically, but I'm just interested to know how to run through thinking about making changes to a global service.
Sure. I mean, I think that ARM actually does stage a lot of its changes. Each of our releases stage through various regions, and I'm pretty sure that Entra does the same as well. I think the challenge arises when there are core concepts like tenants or access control or policy that the end user really expects to be global in the steady state. If I go in and I set policy that says, you must put antivirus on a machine and you create it in Azure, I don't expect that. In fact, I would be very annoyed if it took a week for that policy or even 24 hours for that policy to spread across to all of the Azure regions. And so that means that, we have to think about other ways like per tenant rollouts. And in general, I think that's sort of, we do safe deployment, but we do it on other dimensions like tenant or subscription or otherwise. And obviously in this particular case, it was being done on a single tenant. It just happens to be the case that because of the bug in the initialization logic of ARM, that operation on a single tenant was impactful to everyone. And I think that's why the other part of the lesson, which is to move that kind of loading into the request path, into the on-demand path, because then it's going to be limited. The per tenant thing will mean that the blast radius is necessarily limited because fewer requests coming through those paths will have that change on them. And I think that's how we manage to make sure that these changes stay safe going forward.
And Nadeem, any pearls of wisdom to add about running your global services and making changes?
It's very similar. We mandate that all changes to the infrastructure itself, code, config, machine learning models, any kind of mutation of the service goes through a safe deployment process. We also have isolation. Obviously, we're deployed across every region, but on top of that, Entra has the concept of cells, where the architecture is subdivided into over 100 separate blast containment isolation zones. But again, Brendan, I think, highlighted the really important point. That's the infrastructure. A tenant itself has policies that an end user, an admin of a tenant, may choose to set, and it's a design objective of that customer to set that policy in some cases for security reasons. Instantly. And so services that integrate have to be able to reason over that and make sure that they're resilient and tolerant to these changes.
Yep, that's good to hear kind of answers from both of your sides here. I know we touched on some of the repair items and learnings, especially with respect to monitoring. Brendan, is there anything else that you want to talk to as far as things that we've learned or changes that we're going to be making moving forward to de-risk failure modes like this?
Yeah, so I mean, Nadeem talked a little bit about the cell-based architecture that Entra has adopted. And actually, I think ARM is on a path to build similar sort of structures. And then the interesting question that we've been discussing there is, how do you, once you have cells, what do you partition on? I think for Entra, it's fairly obvious that you would partition on tenant. I think for ARM, it's a little bit more complicated because if you partition on tenant, for example, you may limit the blast radius to certain customers. But for those customers, they'll have a very bad time with their ARM resources. If you say, for example, partitioned on subscription, you would affect probably all customers, but only a subset of their resources. And I think, we're going to go through the math of what makes more sense, what fits with the user's expectations. I think the good thing that will come out of that as well, though, is that we will have the ability to steer particular tenants to particular locations. And we've already been talking, perhaps to your earlier point, about steering all private preview features to a single cell rather than having, the private preview features or preview features in general be available until they're generally available, or at least until they're available to every customer. Steering them into a location where that blast radius can be confined as well. I think that's, we have to have the same code in every cell, because that's the only way that you can, have consistency and reliability, but we can have, differences in configuration between those cells that, perhaps, turn on some features. And in fact, that configuration is how we managed to recover so quickly. Once we determined where the problem was, we could turn off the feature with a dynamic configuration push. That config push actually was global. It's an interesting story in some sense related to this blast radius thing, because it was actually challenging. We've put up enough safeguards to prevent people from making global configuration changes, that when the time came that it was necessary and valuable for us to make a global configuration change, we actually had to jump through some hoops in order to make that happen.
Thank you for running us through that. It's great to hear. Actually, I really appreciate the transparency in terms of, hey, here's the different things that we're exploring on how best to solve this problem. We don't have the answer right away. And, like you say, sometimes the safeguards that we put up to save us sometimes get in the way when it comes to mitigating. So thank you for running us through that. Mindful of time, I generally save the last question for my co-host, Sammy, here. Since Sammy runs our Azure Communications team, I wanted to check in to see, how did we do? How did we communicate with customers during this incident? I know multiple regions, multiple services. It sounds like a complicated thing. Did we keep our customers posted?
In general, we're trying to remove humans from the element of communicating quickly. So our automated communication system, our brain system, sent communications out to a lot of customers as it was happening. Now, the services and scenarios that we've onboarded to Brain, we haven't got everything down yet, but we have a lot on. A lot of it was ARM-based, and so as customers were trying to spin up VMs or trying to scale their web apps, they would have received a notification saying, hey, we're having an outage, here's the tracking ID, and you're having an issue. It's an us problem, not a you problem, which is really what we want to tell customers. Because of the nature of this outage happening in different regions across different services, correlation was extremely tricky. And because of, typically we onboard services and scenarios in the way we do safe deployment, which is region at a time, zone at a time. And so our brain configuration is kind of optimized to say, hey, these things are happening in the same server, the same region, the same time. But because it was ARM, because it was global, it made it very tricky. When we saw the issue was expanding and it was broadening, typically we communicate to customers directly through Azure Service Health. When that impact is growing so quickly that we can't keep up with impacted customers, we'll tend to go to the status page and we say, okay, it's multi-service, it's multi-region, it's a problem. One of the things that customers gave us feedback on and we need to go away and figure out is, at the top we said, hey, ARM is having an issue and it's impacting services, whatever you're trying to use the control plane for. But customers still look at the services with the green ticks and they say, how on earth can you sit down and tell me that my virtual machines are okay? And we'll try and say, well, it's a service management issue, but then you have things like Key Vault, where the data plane is impacted as well. And so we're trying to figure out the nuance, because when we do have an outage, there are services that come in and they say, hey, I'm impacted. We have an area in Microsoft where services say, hey, this ARM issue is impacting my service. But we need to understand, are you affected or are you impacted? And of course, you might be affected, you might have shared internal workloads, but we're really interested in customer impact. So there's a lot of, we need to go away and think about, number one, how we keep a big list of impacted services updated dynamically, so that customers are not looking at a sea of green ticks and we've just got an error message at the top, but we understand the impact. And then we need to tease apart how, once we mitigate per service, how we can quickly update those things rapidly. When we're dealing with 200 plus services, there's a lot to deal with. And so we definitely have repair items around our brain about how we want to represent things on the status page. And so, yeah, in the worst case, customers would have had multiple tracking IDs because brain fired multiple times and didn't correlate them. But yeah, so we definitely have a lot of repair items to do. We are hoping that the transparency in the sessions like this kind of restart rebuilding some of the trust that we have. Yeah.
Great. So learnings from a comms perspective and some learnings for ARM and other services there included in the post-incident review. Well, we're mindful of time, so we're moving to the end of our session here. Thank you to everyone who joined us. Special thank you to Nadeem and Brendan for dialing in and explaining what this looked and felt like to your customers and your services. Thank you to all of our Q&A moderators as well. We've got those subject matter experts who have been answering your questions during the session. Most importantly, thank you to all of our customers and partners for dialing in and hearing the conversation today. The post-incident review that we publish after outages isn't the end of the conversation, it's really the beginning of one. And hopefully this conversation has tried to shed some light on the ways in which we're still learning, still improving. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alert set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.
Thanks.